the basis of everything. NumPy is the basis of everything data science. Is the basics of everything data science. NumPy is what works behind the scene for pandas, for even libraries like TensorFlow, PyTorch, and the rest. You still use NumPy somehow. If you're familiar with the code, you see that there are places where you put .numpy and maybe you want to plot, you want to remove them from tensors and things like that. So it's very important to understand NumPy because when you're dealing with data, with numbers and the rest, you need NumPy. And we'll look at why. So firstly, we'll look at understanding why NumPy is essential for numerical compute. And then the next thing is to know the limitation of Python list, because that's even part of the reason we need NumPy. And then NumPy arrays, how to use them, how to create them, how to perform vectorized operations and things like that. And then another way is I would like to just briefly show Julia, because in Julia is you have the arrays and you don't really need to use any package for any NumPy, but that's just to contrast why instead of just using Python list, you have to use NumPy. So in the beginning, we will look at Python. Why not pure Python list? So you have Python. In Python, you have lists. So you can just call the elements and the rest. So, but in list, if you want to perform a simple plus, let's say you have this list on the screen, you have X as 1, 2, and 3, and then you have Y as 4, 5, and 6. So if you want to just add them up, you can't just do X plus Y. If you just do that in NumPy, in Python, it's going to just concatenate the list. You're going to have a list of 6 elements, 1 to 6, and that's not what we want. We want to sum them up. So a way to do them that will look at least a way to do them that will even make it maybe a little Pythonic and with less code is use list comprehension like I did here. So you can say A plus V for AB in zip XY. So you're going to do this. But part of the limitations I'm giving here is that the list comprehensions can get messy. Maybe you have like 3 lists that you want to add or things like that, or you want to multiply the first one and then add to the second one. So it can get somehow it will not be easy for you to coordinate and organize the code. And then the another factor is there's no type enforcement. We all know that in Python list you could put whatever you want. So the first element of the Python list can be an integer, and then the next one can be a string, because a list can accommodate all that. So since there's no type enforcement, it's really hard for you to be able to coordinate the calculation, because there will be times where things will not be as you want them, because plus will still work even if it's a string, but the result will be different. So that's one thing with Python. And then the most important thing is that there's poor performance for large scale data. So when you have a large data set, maybe you have 500 items, 1,000, tens of thousands in the list, and you want to sum them up, it's going to be so slow, because normally there's this complaint about Python being slow. So it's going to be super slow. So apart from the fact that the code is not easily organized, it's extremely slow. So that's why you cannot just use a Python list, despite the fact that it's good, or anything in pure Python. That's why NumPy comes in, for you to be able to perform computations using the NumPy array. So the basic thing, NumPy, that's numerical Python, that's what it stands for. And then in NumPy is a library that you use for calculations, but normally the backend is written in C, or in some cases C++. So that's Python has this two language issue, where the main language, most of the things you optimize is written in faster languages, because that's how you can get the speed. Python is not as fast as we would like, especially when you're dealing with large data. So the reason for using NumPy is the multidimensional array object, which is very important. You have an array object where you put your numbers and figures, anything you want. And the array object is very diverse. It's multidimensional. It can be one-dimensional, maybe a column or row vector. It can be two-dimensional, like matrices. It can be multi-dimensional, plenty dimensions, like maybe when you're dealing with pictures, and the rest is multidimensional. So it depends on your needs. And then there are vectorized operations. So instead of performing operations at once, performing operations singly, you perform everything at the same time, which is faster. And there's also broadcasting. So when you have two shapes that are not exactly equal but could be broadcasted, we'll give an example of broadcasting later. You can do, maybe you have a 2 by 1 matrix and another 1 by 2. You could broadcast them so that everything will work together. And then there's memory efficiency and performance, which is highly important because in the end, Python is not as fast as we would like. So with NumPy is fast. The back end is in C, which is fast. So you're able to get it to be fast. And then there's memory efficiency too. You don't need to keep large amount of this thing in memory, especially with the vectorized operations. You don't need to maybe initiate uh, initiate a data structure to keep things or things like that. And then another basic important thing which I've mentioned is that it's the backbone of scientific Python. NumPy is what you build upon for every other thing, for pandas, for matplotlib, for TensorFlow, PyTorch, all those things. NumPy is kind of has a role in all of them. So that's why NumPy is very important for everybody to know about and to learn it. Then importing NumPy. So if you want to import NumPy, firstly you have to install NumPy on your computer if you don't have it installed, and then you can install it simply using pip, that's pip install numpy. And then after installing it, to import numpy, you just import numpy as np. So there are different ways to import. You could decide not to use it as np, but np is a popular alias. That's the so what we call alias is when you import something and you name it as something else. So if you import numpy only without putting the as, it means if you want to call up any numpy function, you have to write numpy numpy dot before calling it. If you want to call array, numpy dot array instead of writing np dot array. So the way you call it, import numpy as np. So it's always advisable to use the popular alias because that's what other people will use, and that's what will make your own code very reusable. So if you use import numpy as numpy, it will be the same as np. It will be the same as what others will do, and others will understand your code easily. But if you call numpy as anything else, maybe you put your numpy as ny or something, then you have to be really clear that you gave it a different name. Otherwise, people will be confused because there's a normal way of aliasing for each of the libraries or packages. So NumPy, normally people import it as NP. So once you import NumPy as NP, any function you call, you put np dot this, np dot that, and then that's how you do. So the next thing is, okay, creating arrays. So if you want to create an array, let's say you have a list of numbers and you want to create a NumPy array. Like we said, you can't use just a list because there are a lot of things, manipulations you can't do easily with a list. But if you have a list, you can convert it to a NumPy array using the np.array function. So np.array in your bracket, then you put in the list. So in the first example, np.array, then put in the list 1, 2, 3. So with that, I will get a NumPy array 1, 2, 3, and then I'll be able to perform any calculations I want to do. I can easily multiply it by 2 raised to power this, and it's going to perform it for each of the elements in the array. And then you can also initialize arrays using zeros. So that's np.zeros. For that one, you pass in the shape that you want as the first argument. So you can pass in maybe 2, 3. That means I need 2 rows and 3 columns. So 2 rows and 3 columns, and then you get that. And then there's np.ones too. So after np.zeros, there's np.ones. It's also the same. You pass in the shape that you need. So if you put np.ones, it's going to give you an array of all ones, 1, 1, 1 inside. So it's easy. Sometimes you need these arrays to initiate if you're going to do something, and then you maybe add them up as you perform your calculations, depending on use cases. So np.15 will just give you maybe a straight row of just 5 elements, all of them one. And then if you want an identity matrix, there's np.I, that's EYEI. So also you give the this thing. So if you put np.I3, so identity matrices are always like square. So if you put np.I3, it's going to give you a 3 by 3 identity matrix. That's 100,010,001. And then there's np.linspace, where it's kind of split it for you. So 0, 1, 5. So between 0 and 1, it gives you 5 intervals: 0, 0.25, 0.5, 0.75, 1.0. So there are a lot of NumPy functions to learn, but it's easy to just understand the basic, the initial ones, and then with practice, a person can get better with the numerous functions depending on what somebody is using. And then the next one is array attributes. So you have an array, and then, like we said, one of the most important aspects of NumPy is the NumPy array. So you have a NumPy array, it has attributes. So it's very important to understand what a NumPy array is. So for instance, you have this. So each of the square brackets separated by a comma is a row. So the first row is 1, 2. So for this array we are initiating, is the first row is 1, 2. That's this row, and then the second row is 3, 4, 3, 4. So you have the first row 1, 2, and the second row through 3, 4. So x dot shape will give you the shape, which is 2 by 2. This is the first row, and then this is the second row. You have 2 rows and you have 2 columns. That's 2 by 2. And then you have s dot ndim, that's number of dimensions, 2 dimensions, because you have the row dimension and you have the column dimension, that's 2. And then the data type is the data type. So there's type enforcement in NumPy. So you're going to have only one type. So x dot d type will give you int64. So it means all the items in this array are int64. So they are integers. And this means that this makes your calculation very easy. It makes computation fast because they are all of the same type, and it's easy for you to perform calculations. Let's say these are all integers, you multiply them by 2. It's very easy. But maybe let's say you have some integers, some floats, and the rest. It kind of brings some complication and it can make things slower. So that's one of the beauty of this. So it's important to understand the dimensions. If you put brackets, square brackets, and then separate them with a comma, you have a row. So this first one is a row, 1, 2 is a row, and then the second one, 3, 4 is a row. Then 1 and 3 is a column, 2 and 4 is a column. So that's for 2 by 2. You can also have more dimensions, but I think it's better to just stick with 2 by 2 right now, 2 dimensions. Then as somebody gets more comfortable and more familiar, you can look at other dimensions. So that's for array attributes. The next thing is vectorized operations. So like I said, in the beginning, you can't just add lists. If you add a list of numbers, it's going to concatenate the list. So it's going to give you a longer list. It's not going to add the numbers inside. But for NumPy, it's for calculation. It's going to add the numbers as you want. So let's say for the first one, x is equals to np.array. That's the formula for creating an array from maybe a list. So you have np.array 1, 2, 3, and then the second one to np.array 4, 5, 6. So if you print x plus y, it's going to sum them up: 1 plus 4, 2 plus 5, 3 plus 6, as we want. And then you have 5, 7, 9. And then if you multiply them, it's going to multiply element wise too. 1 times 4 giving you 4, 2 times 5, 10, and then 3 times 6 giving 18. And then if you do x raised to power 2, the same thing. So 1 raised to power 2, 1, 2 raised to power 2, 4, 3 raised to power 2, 9. So it may look something simple, but it's something that optimizes the operations we want to do. Because using pure Python, you can achieve this fast. You could achieve it, but it won't be fast. And when you have bigger and bigger data structures, it's going to be extremely slow. And that's why NumPy makes things super easy, and that's why it has this utility. That's number one, the arrays. So you have the vectorized operations on the array, and then there's also what we call broadcasting. So for broadcasting, it means the shapes are not the same. So as an illustration, like I mentioned in the beginning, each square bracket separated by a comma is a row. So you have this. So what you have is a matrix 1, 2 as a row, then 3. So this is a 3. This is a 3 by 1 matrix. And then you have this is a 3 by 1 matrix. That's 3 rows, 1, 2, 3. And then you're summing with 10, 20, 30. And this is 10, 20, and 30. So you have 10, 20, 30 as a column, and you have 1, 2, 3 as a row. So what it does is it's going to just it's going to make it is going to broadcast it so that you have an answer for what you need instead of it to just go like that. So you have 1, so it's add. So 1 plus 10 gives you 11, 20 plus 1, 21, 30 plus 1, 31. So it brings everything down. So this 10, it gives 10 here, another 20 here, another 30 here. And then the same thing down here. So you have 10, 20, 30 down, and then it adds them up. And then you have the final answer here, where it's going to add everything up. So that's broadcasting. The shapes are not the same. This is a row, this is a column, but it broadcasts everything so that you still have an answer. It doesn't throw an error, because there are instances where that's actually what you need. So if that's not what you need, you need to put guardrails to prevent that from happening. But in NumPy, you have broadcasting, which is a very good operation where you still have answer even though the shapes do not match. So it's really important to understand shapes in NumPy array, what constitutes a row, what constitutes a column. It may not be obvious in the beginning, but with time and with practice, a person can understand the differences. So once you understand the differences between a row, a column, and then let's say the 0 dimension, the 1 dimension, it's easy to even call up operations. So here now, let's say, okay, in Julia, that's another programming language. You don't need, you can define arrays like this, just x plus y, and then if you want to vectorize them, you just put a dot. So you just put a dot, x dot plus y, and then you get the sum. It's going to work the same way as a NumPy array. It has it broadcasts and it also vectorizes. So that's the difference between, let's say, in pure Python you don't have that, and that's why you need NumPy. So if somebody's working with Julia, for instance, you don't need NumPy, just to use the dot syntax, and then you add everything up. If you lost, it's going to behave the same way like a Python list. So this is just for comparison. And then another part of NumPy arrays, which is important for us to understand, is indexing and slicing. So indexing means for us to be able to get each of the items. So like I said in the beginning, this 1, 2, 3 separated by a comma in square bracket separated by a comma is a row. So we have this 1, 2, 3 as the first row, 4, 5, 6 as the second row. So this is the matrix. You have 1, 2, 3, 4, 5, 6. And then if you write the first one, that's x, you put the square bracket 0, 1. That means you want the first row, because there's 0 indexing in Python. You want the first row and the second column. So first row, second column, that means the answer is 2. So first row, second column, the answer is 2. And then the second one, to index everything, if you want the entire row, you put a colon. So if you put a colon in the row and then a comma and 1, that means this is all the rows, but you want the second column. So that means I want the second column, that's here, 2, 5. And that's why the answer here is 2, 5. And then for the last one, that means 1 and then the entire column. So I want the second row. Since there's 0 indexing in Python, 0 is the first row, 1 is the second column, second row, sorry. So the second row is this 4, 5, 6. And then this colon represents everything. So if you want to index, if you put a colon in place of either the row or the column, it shows that you want everything, you want the entire row, and then you now select the particular column you want. But if you want to maybe select just an element, you can put the row and the column together. So I want the element in the first row, second column, which is this first one, and then I get to. I want the entire rows, but just the second column. That's one. Then I get this 2 5. I want the entire second column, second row, because the first one is the row, and then the second one is the column. So some of these things, yeah, is while explaining, I know some people may not understand, but with time, if you look at it carefully, practice it, you understand. So in it, it's important to understand the shape. So the shape is okay. You arrange it. This is the row. This is the column, and then understand how to slice an index because it's important. So you use a square bracket notation. The first an element is the row. The second one is the column, separated by a comma. So that's all. So you can either select elements or you can select entire rows. If you want to select entire rows, you just put a colon. So if you put X and then put colon, comma, colon, that means you want everything. So it's going to give you a copy of everything because you selected the entire rows, the entire column. So if you search colon for the row and then you select a number for the column, it means that you just want a particular column, but you put the entire rows because you don't want just one item. You want the particular column. And then if you want just a row, you put the row number and then you put a colon for the column, and then you get the column that you need. So that's about indexing and slicing. It's basically the same with normal Python, pure Python, when you're dealing with indexing lists. Okay, this is the first element of a list, this is second element, and the rest. The difference is just that in NumPy it's multi-dimensional. And like I said, we are sticking with just 2 dimensions because the dimensions could extend. You could have 3 dimensions, 4 dimensions, depending. But as you go more than 3 dimensions, it's harder to visualize. So it's important to understand 2 dimensions first, and after that, you begin to look at other dimensions as your understanding improves. But understanding the basics is very important. What constitutes a row? What constitutes a column? How to differentiate them, and then how to index them, how to slice. So this is the syntax. And then the next thing is, yeah, apart from the normal indexing where you put numbers and the rest, there's the Boolean indexing. So in Boolean indexing, in Python as well as other programming languages, a Boolean is something that evaluates to a true or false. So if you have anything that evaluates to a true or false, you can use that for indexing to in NumPy. So with the NumPy Boolean indexing, anyone that is true, so true can easily be converted to 1 and then false to 0. So what it does is that anywhere is true, it brings you back the element. If it's false, it doesn't bring back. So in this particular example, we have 1, 2, 3, 4, 5, and then our condition is that x is greater than 2. So for each element, is going to evaluate whether it's true, and then it gives the answer. So for the first one is not greater than 2, so it's going to be false. For the second one, 2 is not greater than 2. On the contrary, 2 is equal to 2, so it's also false. But here you have x, which is 3, is greater than 2. So you have 3, 4, 5 as greater than 2, which evaluate to true. So since they are true, the answer is going to give with this Boolean indexing is 3, 4, 5. So it means in all the elements where it evaluates as true. So this works because and this may sound so trivial because it's just a small example, but when we look at the when you are looking at a bulky data set, a long table, it's easy for you to just use something like this to evaluate for a condition and filter out things. So that's Boolean indexing. You don't always know the location of the item you're looking for, but you know the condition. So this is maybe greater than 2 or equals to this or things like that. Once you put that, you can do the Boolean indexing and you get the particular elements of the array that you need. So all these are important characteristics of the array that you can use. So the next one is aggregations on the array. So that means we are performing calculations using numpy functions on the arrays. So the first one is 1, 2, 3, 4. So like I mentioned, if I want to represent this in a matrix form, I will just have, if I want to represent this in a matrix form, I will just have 1, 2, 3, 4. So I'll just have 1, 2, 3, 4 as a. So the first one is the row. So you have the first row 1, 2, and the second one 3, 4. Second row 3, 4. So if you want to do the sum, so if you pass the sum without giving anything, it's going to do the sum of everything, regardless of whether it's a row or column. So you have 1, 2, 3, and 4. The sum is 10, and then x dot mean is going to give you the mean. So the mean of everything. So the sum is 10 divided by 4, you get 2.5. But if you want to work based on the dimensions, you have to pass in the axis. So you pass in the axis argument and then you give it a value. So when you're looking at when you're looking at numpy arrays, you have 0 and 1. So it's very important we understand what they stand for so that we can be able to look at it. So we need to understand, okay, what does 0 means in the num? What does 0 means? So when they say 0, when you're going down, that's 0. When you're going across, that's 1. So it's very important to differentiate them and then to be able to understand the differences. So once you have 0, so this is the axis 0, and then there's the axis 1. So basically, when you're looking at the rows, when you're going down is 0, when you're going across is 1. So we have here x dot max axis is equals to 0. So it means when it's applying this function, it's going to be going down. So it's going to be going down. It will look at this column 1 and 3 is going down. So the max is 3. So it's going to give 3. And then it will look at the second column 2 and 4 going down. The max is 4. It's going to give 4. So you have maximum as 3 and 4. But let's say if your axis is 1, it's going to be opposite. It's going to go across. So it's going to look at 1 and 2. The maximum will be 2. It's going to look at 3 and 4. The maximum will be 4. So it will be 2, 4. So it depends on what you pass in. So it's really important to differentiate between which axis am I using? Is this axis equals to 0 or axis equals to 1? And the best way is just to practice. Just create an array on your computer, put in axis equals to 0, axis equals to 1. That's the only way a person can easily remember and understand the differences. So it's important this thing. So when you look at an array, when it's called, you should be able to recognize these are the number of rows, these are the number of columns, and then the number
Sir,
of dimensions.
sorry to disturb, sir. Can you please change the color to black?
All right, all right. Okay, so hope you can see this. So I was explaining so we have a matrix like this from this numpy array. So I was explaining that going down is axis equals to 0, and then going across is axis equals to 1. So anytime you're calling a numpy function, if you don't give an axis, it's going to perform the operation on everything. Like this x dot sum is going to sum everything, and then you have 1, 2, 3, 4, giving a sum of 10, and then mean 1, 2, 3, 4. The mean is 2.5. But when it comes to this max, I put the axis as 0. So when its axis is equals to 0, it performs the operation going down. So it looks at this column 1 and 3 and goes down. The maximum of 1 and 3 is 3. And then for the second one, the maximum of 2 and 4 is 4. So you have the answer as 3, 4 here. So, but if your axis is 1, so it's going to go across. So it will look at 1 and 2 and select 2 as the maximum, and then 3 and 4 and select 4 as the maximum. And the same thing can be done for sum and mean too. So we can say x dot sum axis is equals to 0. So in that case, we'll just sum 1 and 3 and get 4, and then sum 2 and 4 and get 6. So it's very important to differentiate between the axis 0 and 1, and to also know what a row means, what a column means. So the next thing is linear algebra. So because there are a lot of functions in NumPy, there are a lot of things that can be done. So for linear algebra, this is an example. So for here to also have the same, I'll still represent the matrix for better understanding. You have 1, 2, 3, 4 because that's the row. So you have 1, 2, 3, 4. You have 1, 2 as the first row, 3 and 4 as the second row. And then you have the function np.linearalgebra.inv of x. So this one gives the inverse of a matrix. So if you want to perform, maybe you want to solve linear equations and things like that, you may need to use inverse and things like that. You may also need to get determinants of matrices and things like, and that's where this linear algebra, this NIL, lin alg, you do that in np.linearalgebra.in.det. There are a lot of functions there for performing linear algebra. And then for this third one is np.x and y. So you have np.x, that's this x, and then y is the inverse. So if you multiply the two together, you get the answer. You get the answer like this. So np.dot here in this particular instance is going to do the matrix multiplication for the two. So most of these formulas, the functions, the best way to this thing is to use them, to practice using them, because there are so many functions to highlight, and then it's not easy for a person to be able to know all of them at the same time. Hello.
Okay, let's check that side for them. But we'll go outside. I will leave
Okay.
you boy now. Only me. No man. Why go line three? How many people line three? Where go to them? How many of them? The other day, what is there? Alabati.
Okay. So the next one is random numbers. So just like we can use random in pure Python, we can use random in pure Python and then initiate random numbers and use. So in NumPy 2 we have that. So another important thing to note in NumPy is that you can use random.seed. So the importance of using random.seed is for reproducibility. So when you use random.seed and then you put a number, anytime you call the function, you're going to get the same numbers. So it's very important. For instance, you're working on a project and you didn't seed your random number formation, and then after finishing everything, you can't reproduce the result. So maybe your result was 68%, and then you were showing your supervisor, and then you were having 50% in the new result. That's because you didn't seed it, so that you're going to get the same thing. There's always some sort of randomization when it comes to things. You may not be able to replicate your values. So when you put a seed, you're going to get the same number as you move. So depend whether it's NumPy or you're using PyTorch, TensorFlow, and the rest, it's important to have a seed. Put the seed so that it's reproducible. So when you put np.random.60 and then you perform these things, these operations, you're going to get the same number always. So that's the importance of using the seed. So np.random.rand, you get this np.random.rand, then you put the shape. This argument is the shape, so you put 3, is going to give you just 3 digits, and then this is random numbers between 0 and 1, and then np.random.randn2, you put 2 2, so 2 2 is the shape. In this case is random normal, that's numbers of in the normal distribution. So you have this thing mostly from minus 3 to 3 basically. And then the third one, np.random.randint. So in this case, you have integers. So you give the intervals where you need. So between 0 and 10, and then you give the size to size equals to 5. So that's to initiate random numbers in NumPy. So most of these functions where you just initiate arrays, most of the arguments are the shape. So that's why it's important to know what a shape is. Like this mp.random.rand here that we added 3. We could put random.rand and then put maybe bracket 3 3. So it means I need 3 rows and 3 columns of the random numbers and I'll get them. So but if you put just 3 like this, it's just going to give you 3 of them straight as a one-dimensional array, and that's all. But if you want maybe something bigger, 3 3, maybe 3 rows 3 columns, like I said, we'll stick to just 2 dimensions here in this our contact. So if you put 3 3, you're going to get 3 rows 3 columns. If you put 2 3, 2 rows 2 columns. If you put 4 4, that means 4 rows 4 columns. So it's important to understand how the rows are, how the columns are. So especially for functions where you initiate arrays based on a particular type, the same thing applies to all the ones we did previously, like zeros, ones, and the rest, where you put the shape. So you put the shape you want. So before you put a shape, you need to understand what you're looking at, and then you add the shape. And then, so basically, in summary, we have numpy arrays were introduced. I wanted to put like more functions, more things in the array, but jam packing everything, I think it's just important to highlight the most important things. And then with the resources that have been shared, the book that has been shared, and there's also an important resource on the repository where people can do people can practice numpy. There's this numpy 100 exercise, so it's on the repository. So 100 numpy exercises, I'm sharing it here. So it's on the repo. So if a person goes through all these things, you're going to really understand numpy. What is it? What shapes are, things like that. So most of these things require practice. Like you practice them, you do them. If let's say you're shown this today and tomorrow you're still shown again, but you don't practice yourself, it will really be hard for somebody to understand the numpy. Or most of these things regarding programming and things like that requires practice. Like you give yourself time, sit down and look at things and make sure you test yourself to know you understand. So with this resource on the repository, 100 numpy exercises, you see it starts from basics like importing, and then it gets more this thing as it gets more advanced as you go down. So please look at that and try to understand and use it, practice on it on your spare time, and I'm sure it's going to be really helpful. And then, like today, we discussed NumPy arrays, looking at simple functions in NumPy, and then understanding vectorization and how broadcasting makes things easier. So, like broadcasting, I explained that when you have shapes that don't match but could be added, so you have that. So I'll really give advice, look at the exercises, practice them, and then if you have questions, feel free to ask regarding that. And then experiment slicing, broadcasting, aggregation, things like that. The only way to really understand is to experiment, especially where I was explaining axis equals to 0, axis equals to 1, things like that. I know it's not something very easy to grasp, but if you practice, put in figures, understand, look at the output it gives, you really get to understand it regarding this thing. So if any questions.
Yes, sir.
Yes, please go ahead.
Yeah, my question is regarding how to shape your columns. That's my first question. If you are trying to shape your columns or rows, assuming I just write, let me say an np dot, let me say zoom, sorry, 0, then I put maybe 2 only. Does that mean I'm going to have two different numbers, or it's just meaning that the two is going to one single row?
Okay, so if I get your question correctly, you're talking about how to put the shape.
Yeah.
Okay. So regarding that, let me see. If you want to put the shape, I want to open a Jupyter notebook and explain. Okay. Uh, okay. Okay. So let me just explain here. And,
Thank you very much.
can you see my VS Code?
Yeah, I can see it because I believe others can see it as well.
Okay. So I've imported NumPy. So we want to put an array of zeros. So you put mp dot zeros and then you put the shape. So if you put mp dot zeros like this, mp dot zeros, then you put what you need. So like this mp dot zeros 3. Let me So mp dot zeros 3. Of course, the content of the array will be 0. So you have 3. So it's going to just give you a row of 3. A row of 3 distinct. So but let's see another one. mp dot zeros, and then if you want to give it the row and columns that you need, you now add a tuple. That's of course a round bracket. So let's say 3 4 now. So 3 4 means I want 3 rows. Look at 3 rows, 1 2 3, and then 4 columns, 1 2 3 4. But the content is already fixed. It's zeros that you need. It's the same thing with mp.ones too. The content is fixed. It's one that you want inside. So what you can only supply is the shape. How do you want the one to look? How many ones do you need? So if let's say you need 4 rows and 3 columns, so you just put them 4 rows, 3 columns, and then it goes like that. Do you understand?
Yes, I understand clearly, sir. And my next question is actually on the same. We can maybe use the same page. Assuming there is no exact shaping of maybe three or four or one, and I just put an empty bracket, what will happen? Is it going to be an infinite size, or what will actually happen?
Wait, I please come again with the question.
What I mean is, if instead of writing or trying to be explicit about the size, what if it is an empty bracket? What will happen to the number to the output?
Well, in the end, mostly when you're looking at these things, there's always a purpose for these things. So mostly when you're looking at, okay, you want to initiate an arrays of zeros or arrays of ones, there's always a purpose for it. Maybe you're working on something and you're going to fill in the values later, or maybe you want to use it as a filter for something that you're going to change. So mostly you have an idea of shape that you need. But let's try to initialize it without putting anything, because mostly you have to put something. So you say you have to put a shape, which is this thing. So you can't initialize it without anything, because mostly it's based on use case. There's always a need. You want to, depending on what you're working on, you have an idea of the shape that you are looking at. So you put the shape and then maybe you're going to fill in with something else later, or you want to use it as a max or something. So that's why mostly people do that. Or you put mp.ones, and then after putting that, you now select you slice a part of the array and put something there. So there's always a reason. You don't just do it randomly regarding initializing the arrays. That's why you put the shape. Let's say you're working with pictures. Pictures normally have pixels and shapes, things like that. So you know that the width is always 3, the channels, and then things like that. So the shape is fixed. So you always, mostly you have an idea of a shape. So you don't really need to initiate something that without shape.
Thank you very much. This is very clear.
Okay.
Hi,
I got
sir.
a question.
Hello?
Oh, should I go first?
Yes, yes, please go.
Okay, thank you. I wanted to know, sir, if we need to push this particular repository onto our GitHubs and whether it'll be used after we finish this particular course to evaluate if we've done all the exercises, or do I just have to work on this repo on my own remotely? Because I asked the very same question in the group, but no one answered me. So I wanted to know basically what was the way in which we're supposed to submit the assignments that come from this repository.
Okay, in that case, I will defer to Dr. Shamsuddin to answer the question.
Sir, can you hear me?
Yes.
Yes, my question is regarding NumPy. So that means we can't use it unless if we are assigning it. For example, like let's say x equal to np.array so and so. So we can't just use np.array without assigning it to a variable.
Okay, so if I sorry, I wanted to get the first question clearly. You were mentioning something about assigning the array to a variable.
Yes, I said. So from this class, if I understand it clearly, it means we can't use np.array unless if we assign it to a variable. For example, in the examples you gave, you said for x equal to np.array so and so. So I don't know. Can we just use np.array and use our values, or we need to assign it to a variable?
Okay, so let me go with the first question first. So regarding that, you can actually use it without assigning, but for you to properly use it, you need to assign. Let's say you put np.array and then you fill in something there and you have an array, and then you now created a second array that you want to use. Maybe you want to sum the two or get the difference. How will you do that if you didn't assign them? Do you get me? Hello, are you with me?
Yes, sir. Yes, sir. I understand your question.
So that's part of the reason you need to assign. But otherwise, you can just initiate your array without assigning it. But if let's say you're initiating like 5 arrays and you want to perform calculations with them, then it's important for you to know what to call them. Maybe you're dealing with A, B, C, D, E, or X, Y, Z, and things like that. So that's why it's good to assign. But you can, if you just want to look at something, practice with it, you can just initiate without assigning.
Okay, sir. Okay, sir. Understand, sir.
Mr. Lukman.
What of the second? Yes.
I have a question.
Please go ahead.
Thank
Sir,
you.
Okay.
Thank you.
Sorry, please.
Hello, please raise up your hand first. And when you are asked to talk, then you can talk. Raise up your hand first because like we are having some issue. Raise up your hand first, then you can be asked to talk. Okay, Mujahid, go first.
Okay, I wanted to ask my second question. The second question is regarding NumPy. So we are using NumPy for calculation. You can't use NumPy for any other reason apart from calculation.
Not really. One thing that you may be shocked to know is that there are even string operations you can do. So it doesn't have to be calculation, just math and the rest. But that's its most important use. So when it comes to that, so if you want to see maybe all the vast number of functions and things like that in NumPy, ufunct and other things, I think you should read the chapter on NumPy in the book that was shared by Dr. Shamsuddin. You see a lot of things that can be done. You can even do things on array on strings. That's normal letters and things like that. So it's not just calculation, but calculation is the most important thing you can do because that's the thing you cannot easily do with pure Python.
Yeah, another thing is NumPy is the foundational to scientific computing ecosystem. When I say foundation, it means all these like LLMs you use, ChatGPT, all these like, maybe whether you are coming from biology, from chemistry, all the foundation of all those, tools that you use, Pandas is one of them. For example, even NumPy, for example, has been implemented in even pandas with NumPy. Even all these, TensorFlow, PyTorch, if you know them, they are built either directly on top of NumPy, or they are designed in a way to work interchangeably. In fact, pandas also, I think maybe was designed on top of, NumPy. And all of these things, you do in machine learning, for example, they come from, for example, using mathematics, linear algebra, and whatsoever. And pandas is the core, part doing all this. So pandas is one of the key stuff even in AI research. I mean, I'm interchanging them in NumPy. And I would highly recommend you read that chapter that I share in the book for NumPy. It will really gives you a very good understanding and many, many other things. And not just to read, but go as you go and you practice I also think Lukman will also share some of the 100 example of NumPy in the GitHub, so that maybe in this week you can practice them. All right, thank you.
Yes,
Okay,
yes, sir.
Abdul Hamid.
Yes, thank you, Mr. Lukman, for this very insightful lecture. My question is, you made mention during the course of your lecture that we must download the NumPy package that is in our VS Code before we are able to start running codes, NumPy codes. So please, I don't know, how can we download it here in our VS Code? That's my first question. And secondly, the second question is, I can see you are able to seamlessly use some rectangular boxes here to perform the coding without bringing out the terminal for the answers, and you get the result of the codes easily without bringing out the terminal panel. So please, you can also help us shed light on that so that we learn from you. Thank you very much.
Okay, so regarding the NumPy, if you want to install NumPy, I'm assuming, let's say you have your VS Code set, you have Python installed, you have a Python installation ready, and possibly you've set up an environment for your code. So if you have all those ready, installing Python is NumPy is very simple. It's just to look at, it's just to, okay, my VS Code is still there. It's just to come here, you put an exclamation mark pip install numpy. That's all. So pip install numpy, and then you can easily import numpy to be installed in your Python environment. So this is the easiest, since maybe you're not familiar with the other methods, but it's the easiest. Put an exclamation mark pip install numpy, and then you do that. So, and then you were asking the second, that's the installing part. It's very simple. So after that, anytime you come up, it's just to use import numpy as MP, and then you can proceed with what you're doing. And then the other aspects, if I got the question right, you're talking about my presentation, right?
No, I mean this box you are using to write your codes. These rectangular boxes you use to write the code and get the answers instantly without opening the terminal. You understand? So I want to also know how to
Okay,
do
are you
that.
talking about the VS Code?
Yes, the VS Code, yes.
Oh,
You are
okay.
writing.
So this what I'm using in VS Code here is the Jupyter Notebook. It's Jupyter Notebook. It was covered during the first part of the Python fellowship. So it's a Jupyter Notebook. Once you open it, you're able to run your code and you get the output. And that's the beauty of it. You don't need to be looking, maybe using the terminal for the Python and things like that. So it's easy for you to run the code, do visualizations, and get the output. And it's very easy for somebody to just run simulations and do things. Once you have a final code that you can use, maybe put to production, then you put them in scripts and things like that. But in the Jupyter Notebook, it's easy for experimentation. So it's a Jupyter notebook, and then it's easy to get started. Just look at there's a part on the VS Code documentation about using Jupyter notebook in VS Code. That's, I'm assuming you have Jupyter notebook. You have VS Code, sorry. So there's a part about that. So it's easy to use. Let me share the documentation in the code in the this thing. And then we have some questions in the chat. The first one is, suppose I have a 3D array and I want to convert it to 1D. How do I go about it? So there's a way to convert. There's a way to convert a NumPy array when you already have the array. So if, let's say, so we have let's say, let me open my VS Code here. So let's say this is my array. Let me change this. So this is a, let's say this is once. So we have this, okay, as the array, and then I can easily change it. So there's the reshape, there's the reshape method. So if I want to make it, let's say, a 3 by 4 instead of 4 by 3, I can just reshape it, and then it's going to become like this. So once you call it dot reshape, there are two ways. Either you put dot reshape on the array, or you put mp dot reshape. So if you use mp dot reshape, you are going to put the name of the array first, and then you put the shape that you want to change it to. So there are two ways to do that. That's for the question on changing the array. And then, like you said, if it's four-dimensional, you can still change it to one dimension by just putting the shape. Once you put the required shape, it's going to be like that. And then the next thing is, okay, the next question. So kernel. So there are other, I don't know, regarding, okay, Mohammed, no, Awal Abdullahi. So, okay, Zaharia Lawal Hassan. My kernel usually crashes if I call NumPy. Well, it depends. Is it on VS Code? There are different reasons for that. Sometimes maybe it's the Python installation. Maybe it's not really supported, and then you can be having your kernel crashing if you're trying to import or do things. So maybe you should look at the this thing installation you have. All right. I think we are done with all the questions. Any other question? Okay. All right. So I think we are done. So regarding the presentation I gave is using Quarto, and the reason I like using that is because you can put code and you can also run the code on the same presentation. That's the code and the output at the same time. Sometimes it's not easy to give them unless you're using a Jupyter notebook. But if it's on a presentation, it's really difficult, especially when maybe you want to present visualizations and the rest. So you have to look for how to show people the images and things like that. But with Quarto, it's easy to write executable code and then show the results at the same point. So thank you. That's
All right. Thank you very much, Lukman. Oh, it's already we have 10 minutes on top of the hour. Yeah, thank you very much. Tomorrow we'll be able to see um pandas. I hope you enjoy today's session. But before that, I'll share my screen just to show you this couple of things. Okay, yeah. So if you look at, this is where we have NumPy, right? I think here we have something called NumPy exercises. The NumPy exercises are here. And, if you go through this one here, you'll be able to see a lot of example. there are 100 exercises, 99. So it's not meant to be like you should do the exercise on 100, but if you really care about how learning, you can go through them, to see which one you can use. We'll upload the recording here for you, and tomorrow will be pandas. And then what Lukman presented today, the slide, will be loaded here in this folder, which is called stage 2 slide. Stage 2 slide, this one, yeah, stage slide. We'll upload this one here. Yeah, any question?
Sir,
So
there's the question on assignment submissions.
Hello? Oh, assignment submission. Okay, I will discuss that one tomorrow. We want to finish the assignment of mentors for each. We want to make some kind of assignment to people, to mentors that will be working through them. Yeah. People who are asking the link for this, our repository, this is something that you all have access to. So this is the machine learning repository. Yeah. We'll discuss about the assignment by tomorrow, but yeah, we want to make sure that the assignment we do for the because we wanna divide the mentees, like each mentee has a couple of mentors that will guide him if you have any issue and something like that. So we are waiting to finish that assignment, that we can tell you how you're gonna submit to each mentor. Yeah. Good. So thank you very much, and I will see you tomorrow. Thank you.
Thank you, Dr. Shamsuddin.
Bye.
Thank you, everyone.
Bye, Doctor.